Okay, next assignment. I'm going to combine 3.1 and 3.2. And we're basically going to be solving linear systems. Your essential question: how do you solve linear systems? Okay, so there are many different types of systems out there. We're just talking about systems of equations. Currently, we are learning still about lines, so the only systems that we can solve are linear systems. Now, what does it mean to solve a system? This is basically where you are going to find the point, and a point is made up of an x-coordinate and a y-coordinate. Where the graphs intersect. And you have different amounts of solutions that you can get. Well, you can get one solution. If it's one solution, it's pretty straightforward. You're going to have two lines intersecting in one point. Your solution will be this point xy that satisfies the equations of both of these lines, which tells you that they have a coordinate in common. Sometimes you will have no solution. And hopefully you're thinking to yourself right now, oh, I know when I have no solution. That's right. It's when you have, let's try and make these look as parallel as possible. Two parallel lines. So I'll put these little arrows showing that they're parallel. Okay, so that's when I have no solution. That's because I have parallel lines. And your other option can be infinitely many. So that happens when both of the equations that you're working with happen to be the exact same line. Right? All these points, every point on the line, they're going to have in common. So this is when we have the same line. And a lot of times, instead of saying infinitely many, I'm going to write infinite or infinity. So that could be an abbreviation for you. So I'm going to do an example where we solve a system, and I'm going to show you 3 different ways to solve this system. Now, of course, it would be silly to say every single time you should solve the system all 3 ways. You're going to need to choose. Anytime that you need to solve a system, you have to choose what's the best way for that system. Okay, sometimes it'll be easier to use one way, other times it'll be easier to use another way. I'm going to show you a way with your graphing calculator, but obviously a lot of times if you don't have your graphing calculator, that's not going to be the easiest way. Alright, so we'll do an example. I'm just going to call it an example because this will be so this is your example, okay? We are going to solve the linear system and check the solution. So here's the linear system. Let's see, we're going to do 3x minus y equals 13. and 2x plus 2y equals -10. Okay, so the first method that you can use to solve is graphing. Okay, so one method, so I'll put a number 1 here. We're going to try this by graphing. Okay, and at this point in your life, if you can't graph these two lines, you have some issues, but I'm going to move on. Okay, and it's up to you to figure out, how do I graph lines? Okay, I'm using my calculator because I want this to go quickly and because I want you to be able to use your graphing calculator. It is a huge, huge, huge resource. Okay, so let me find my graphing calculator. All right, so you're going to go to your y equals, and you're going to clear whatever you have in there. All right, so I need both of my equations that I currently have to be in y equals form, okay? So maybe not, if this was me and I was choosing to solve this, this would not be my go-to method, okay? But this is a good way to get a visual representation of what is happening. So the first thing I need to do is I need to change both of these equations so that I have y by itself. Okay, so I'm going to subtract 3x from both sides. Oops, I just did that. Plus 13. And then divide both sides by -1. That's the first equation. Other equation. Okay, so I'm going to take my graphing calculator now, and I'm going to plug both of these equations into it. So I have my little Wabbit graphing calculator. Let's make sure it's on your screen. No. All right, well, that's how it's going to have to be. So, okay, you want to go to your y equals. So let me get out of here. So when you're just on your graphing calculator, go to y equals. That's where you go to graph. If you have anything there, you want to clear it. And we're going to type in both of these equations. So you already have your y equals. So my first one's going to be 3x minus 13. And my second one's going to be negative. Now the negative is down here at the bottom right-hand corner. And before we graph it, let's make sure we have a pretty decent window. So this second button at the top, you're going to want to press that, and you're going to want to make sure that you have a pretty standard window. So I would go from -10 to +10 in your domain, or your x values. And the same for your range, -10 to +10 for your y values. And then you hit graph. It's going to graph your two lines, and you can see that they do intersect somewhere. You have a couple of options of how to find this, and the most exact way to do it is to actually calculate the intersection. So you're going to hit second, and then trace or calc. You can see that calc up there. So second, trace, and I see option number 5 gives me intersect. Now it's going to ask me, where is your first curve? So right now I don't even see my cursor, so I'm going to hit my buttons. It looks like I'm going smaller, so I'm going to go right now. There it is. So I can see my little cursor. So I'm on a curve. Okay, I agree. That's my first curve. Okay, now it's asking me, hey, are we on your second curve? Let's see. I can see the little cursor right there. So yeah, you're on my second curve. And then it's asking me for my best guess. So I'm going to go to where I think they're intersecting, about right there. And it tells me that my intersection is at 2, -7. Okay, so when I graph this, and I'll just draw a really rough graph of this. Right, I see that this one, okay, it's down here at -13. Great. Okay, and then this other one, well, it's down here at -5. Okay, so I've got a -13 with a positive slope. So I know that that line is going to go, again, just a rough graph. Okay, and then this other one, I'm starting at -5, and I've got a negative slope. Super rough graph, because we used our graphing calculator. And what I would do is, if you are confused about how to use that graphing calculator, I'd go back, I'd watch this video again, and I would write down notes. Notice I didn't write any notes down because I know how to use my graphing calculator. But you should be writing down notes if you don't know. That way you don't have to keep going back and watching the video. All right, so I know that this point right here that my calculator told me was 2, -7. Okay, so I have to check this. Yes, I checked it on my graphing calculator, but let's actually plug this number, this x and y value, or these x and y values, back into our original equations, and let's see if they actually make them true. Okay, so I'm going to do that down here. Let's get rid of my graphing calculator. So I'm going to check. Okay, so for the first equation, it would be 3 times my x value, which is 2, minus y, which is -7, equals 13. So that's 6, minus a negative, that's plus 7. Oh, that is 13. That one checks. Okay, let's do it to the other one now. So 2 times 2 plus 2 times -7 equals -10. So that's 4 minus 14 equals -10. That is true. -10 equals -10. That one checks out as well. Okay, so we checked it, and that's how it has to be. If we're going to end up with a solution, that solution needs to be on both of our lines. And so if we put it back in or plug that solution back into either one of the equations, we're going to get true statements. All right, next way. And this way we've already done. We did this quite a bit, I would say, in geometry. I don't need one there. So in geometry, we would solve using substitution. So our second method would be substitution. So I'm going to go back, and I'm not going to take the equations in this form. I'm actually going to take them in these forms, because this is a great way to use substitution. This is when you would use substitution. See how both of these equations are set equal to y? So I can just take one of these values for y and plug it in to the other equation. Solve for x, get my x, plug that x value back into one of these equations, get my y value, which we did quite a bit last year because we dealt with lines a lot. Okay, so let's do that. So I've got y equals 3x minus 13. And y equals -x minus 5. Okay, so I realize that this piece right here equals y. So why not take this piece and plug it in right there? So I end up with 3x minus 13 equals -x minus 5. All right, so I'm going to add x to both sides. And at the same time, I'll also add 13 to both sides. 4x equals 8. X equals 2. What do you know? Okay, and then I'm going to take that 2 and I'm going to plug it back into either equation. It doesn't matter because remember, they both have the same exact point. So when x is 2, y is -7. So I'm going to plug that in. Why don't I take the 2 and plug it into this one? Okay, so y equals -2 minus 5. Well, that's -7. So my point happens to be 2, -7. Okay? How would I check this? Yes, I would take this and I would plug it back in to both of these equations and make sure that it makes both of those equations true. Or at this point, if you solve using substitution, then you could take both of these equations and you could plug it into your graphing calculator. That's another way of checking. Okay, and I have one more method for you, and this is called combinations. And this is actually one of my favorite methods because I find it to be the easiest. I don't have to get out my graphing calculator. I don't have to rearrange my equations usually. So this is the one that I would use if I wasn't given my equations. For example, if one of them was not already set equal to a variable. So I would use combinations for the problem that we originally got, okay? And what I'm going to do is I'm going to take those two equations that we originally got, and I'm going to set them on top of one another. So 3x minus y equals 13, and 2x plus 2y equals negative 10. Okay, so what you want to do here is you want to create equations where if you added them together, one of your variables will go away. So I can see that, like for example here I have 2y. So if I could get this y to be negative 2y, then if I added these two equations together, the y's would go away. I'd just be left with x. So that's what I'm going to try and do. Now the way I'm going to do that is basically by multiplying this top equation by 2. Could you also make, for example, the x's go away? Sure. You'd have to multiply the top by 2 and the bottom maybe by negative 3, so that, one would be positive 6, one would be negative 6, and those would go away. But instead of multiplying both equations by something, I'm just going to go ahead and multiply the top one by 2. So my new equation then becomes 6x minus 2y equals 26. Okay, then from there, this bottom equation can stay exactly the same. So I'm just going to go ahead and rewrite it. 2x plus 2y equals negative 10. And now what I do is I add them together. Just straight up and down. So 26 minus 10, that's going to be 16. Bring down my equal sign. Negative 2y, positive 2y, those cancel out. That's my goal, is that one of my variables cancels out. And these two together, add them, you get 8x. Solve for x. You get x equals 2. How do I find y? Yes, I take this and I plug it back into either equation. Okay, so I'll take 2, plug 2 in there, plus 2y equals negative 10. 4 plus 2y equals negative 10. Minus the 4 from both sides. 2y equals negative 14. Therefore, y is negative 7. And again, how would you check? You're either going to take this point, plug it back into both of the original equations, or you're going to graph it to double check. Okay? So 3 ways of solving. Now, the combination way gets a little bit weird, because sometimes when you're doing combinations, you may end up with x not equaling something. Okay, so what happens if you add two things together and you get some weird statements? Okay, so let's try that. Let's try one where we get some weird statements. Okay, so let me give you another example. Okay, so I apologize. I wasn't going to use another example, but let's go ahead and do that because I want to show you where you might get some of these weird statements. So let's say, for example, I have negative 2x plus y equals 6, and 4x minus 2y equals 5. Okay, again, I see that my y's could easily cancel out. Oh, so could my x's. Why don't we go ahead and do the x's? Let's cancel out the x's. So what would I need to multiply the top by in order to cancel it out or have it be completely opposite with this bottom? I would need to multiply it by 2. Okay, so my new equations become negative 4x plus 2y equals 12. My other one just stays the same. Okay, so I see my x's go away. Awesome. Well, so do my y's. Uh-oh. So I just got rid of all my variables. So this gives me 0 equals 17. Is that a true statement? Does 0 equal 17? That is not. That is a false statement. So I just got a false statement. So if I get a false statement, that is telling me that these two lines are parallel. So I have parallel lines. So how many solutions? No solution. Okay, so a false statement means parallel lines, no solution. Okay, that happens to be this situation. There's one more situation. I might get, okay, so something that could happen maybe would be like a true statement. Maybe you get a statement where, 7 equals 7 or 0 equals 0. That's a true statement, or those are both true statements, right? That tells me that these two lines are the same line, and therefore, how many solutions do I have? I have infinite solutions. Okay, so this is some important stuff here. Let's see if I have a highlighter nearby. So we've got a false statement means that we've got parallel lines, no solution. A true statement means that we have the same lines and therefore infinite solutions. And it might also be important in your notes to go back and say, hey, what are my 3 methods for solving linear systems? One of them's combination method. Make sure you get this one down, because we're going to take this one and we're going to end up with 3 equations with 3 variables. So if you can't do this in 2 variables, there's no way you're going to be able to do it in 3 variables. Okay? Substitution, really, really useful when one of your equations is already solved for one of your variables. It could already be solved for x too, and then you just take that x value, plug it into the other equation. And the one that is the hardest, which I don't recommend unless you have your graphing calculator and some, or really, really, really great graphing paper and some ruler maybe, it's graphing. Okay, it's a great way to check. You need to be good with graphing. Like I said, if this is hard for you to graph on your own without your graphing calculator, you're falling behind, and it's time for you to learn how to graph these things, okay? But I also need you to learn how to graph them using your graphing calculator. Now, linear systems are used all the time in the real world, and they're used a lot in business, trying to figure out ways to maximize profit, minimize costs. So we're going to, of course, do some word problems where maybe we could see an application. So we have this example that I copied out of my teacher edition. That's why it's called Extra Example 5. And we're going to go ahead and work on this. So we have a citrus fruit company plans to make 13 1/4 pound gift boxes of oranges and grapefruits. Each box is to have a retail value of $21. Each orange weighs 1/2 pound and has a retail value of 75 cents, while each grapefruit weighs 3/4 pound and has a retail value of $1.25. How many oranges and grapefruits should be included in the box? Okay, so this is a lot of information, and the best way to deal with all this information is to organize it in a chart or in a table, okay? So what information has been given? Well, I have type of fruit. So that's going to be one of my columns. I know, well, actually, I don't think I know this, but I need to know the number of each fruit. I need to know, or I think I have the weight or the pounds. How about pound per fruit? I also happen to know how much each fruit costs, so I'll put the money per fruit or the cost per fruit. I have a total weight and total cost or total money. All right, so what are my two types of fruit? Well, one of my fruits is an orange. My other fruit is a grapefruit. Okay, do I know the number of either type of fruit? I don't. That's actually what I need to figure out, right? How many oranges and grapefruit should be included in my box? So I don't know. So why don't I let oranges be O and grapefruits be G? Will orange be confusing because it's an O? Maybe. Maybe we shouldn't use an O. How about N? Okay. Now my pound per fruit. Let's see. So each orange weighs half a pound. And each grapefruit weighs 3/4 of a pound. All right, how about the cost per fruit? Let's see. So an orange has a retail value of 75 cents. And a grapefruit has a retail value of $1.25. Okay, now I need a total weight for each of these fruits. So my total weight is going to be the number of each fruit times the pounds per fruit. So that's going to basically be a variable expression that I can write as 0.5 n. And the same thing goes for grapefruits. So let's see. So pound per fruit is 3/4 of a pound. Number of fruit will be G. So total weight is going to be however many grapefruits times the pounds per grapefruit. So 0.75 G. And total money is very similar. So I know that a grape or an orange will sell for 75 cents times the number of each fruit that's sold. That's going to give me my total money that is earned. Okay, so 75 cents times N. I kind of ran out of room here. And then for the grapefruit, it's going to be $1.25 times the number of grapefruits sold. So 125 G. Okay, so now I have enough information where I can basically write two equations. Oh wait, I have one more thing. So they are going to make, let's see, the total pounds is going to be 13¼ pounds. Okay, so my total weight here, right, this part right here needs to end up being 13.25. Okay, and then my total cost says each box is to have a retail value of $21. So my total cost under this column is going to be $21. Okay, so now I have enough information. I have some variables, I have totals. I can end up with a total weight equation, and I can end up with a total cost equation. And because I have two equations with two variables, I can solve those to figure out how many grapefruits and how many oranges I should have. All right, so I'm going to have my first equation going right down here is 0.5 n plus 0.75 g equals 13.25. Okay, my second equation is going to be 0.75 n plus 1.25 g will equal $21. Okay, so when I'm looking at this, I want to figure out Well, at this point, you have many options, okay? You can say to yourself, all right, let me go ahead and solve for one of these variables and graph it. Or solve for one of these variables and use substitution. I'm going to go ahead and use combinations, okay? So I think the first thing I want to do to make this a little bit easier for my eyeballs is I'm going to change it so that I don't have any decimals. I'm going to clear my decimals. So the way that I clear decimals is I basically look for my most decimals. I have 2 here. And I multiply by something with that many zeros. So it looks to me like I need to multiply top and bottom both by 100. Okay, so this one's actually going to become, actually, why don't I move down and over. So this equation right here will be 50n plus 75g equals 1,325. And this equation will be 75n plus 125g equals 2,100. So a little bit easier to see if I don't have decimals to worry about. All right, so let's see. I think that both of these two numbers can become the same. Okay, so I think that 75 times 2 will give me 150, and 50 times 3 will give me 150. So I need to make one of them negative. I don't think it matters which one we do. How about if I do the top one? So I'll multiply by a negative 3 and a positive 2. Okay, so I'm going to go straight over here and do that. So I got negative 150n, minus, well, 75 times 3, that's 225, I believe. And then, well, 1325, I don't know that. $3,975. And that needs to be negative as well. Okay, next one. Going to be positive 150 n positive 250g equals positive 4,200. And I'm going to use combinations and just add these together. So my n's go away. Looks like I'm getting 25g equals, let's see, is that 25, 225? So I'm getting the fact that the grapefruits, if I divide both sides by 25, 25 will go in 4, 8, 9 times. So I know I'm going to have 9 grapefruits. And then how am I going to figure out my number of oranges? Well, I'm just going to pick an equation and plug it back in. Okay, and I think instead of using decimals, I'm going to go ahead and use one of these. So why don't I go ahead and plug it right back into this first one here. So 50n plus 75 times 9 equals 1325. So let's see, 75 times 9, 675. So 50n plus 675 equals 1325. I'll subtract. $50n equals $650. So n, let's see, 50 will go in 13 times. So I have 9 grapefruits, and I ended up with 13 oranges. Okay, so I want, let's see, how can I write this? I need 13 oranges and 9 grapefruits in these fruit baskets.